Hello everyone, this is CA Archana Mittal. Welcome to CBSE Specialist. This is second tutorial to the subject Chapter Light, Subject Physics Class 10. In this tutorial, we are going to study about refractive index. In order to understand the refractive index, first let us conduct a small experiment which can be very easily conducted at home with the help of a coin and a tumbler. Take a tumbler or a container. Place a coin at the bottom of that container. Fill the container slowly with water. You will observe in that case that the coin appears to be raised from the actual position, though actual position remains the same. Why is this thing happening? We saw in earlier video that light travels faster in optically rarer medium and slower in optically denser medium. When we compare the speed of light in two medias, it is known as refractive index. The ratio, when we are comparing the ratio of speed of light in vacuum or in air to the speed of light in medium, it is known as absolute refractive index or simply the refractive index. Here, in place of vacuum, we can take air also, because the speed of light in air is almost equal to the speed of light in vacuum. We can study this with the help of an example. You have to find it out yourself. What will be the refractive index of glass here? The formula will be speed of light in air by speed of light in glass. So can you please tell me what is the speed of light in air? It is 3 into 10 raised to 8 meter per second. And speed of light in glass is 2 into 10 raised to 8 meter per second. Refractive index has no units as it is the ratio of two velocities. A medium with higher refractive index is said to be optically denser medium, and medium with lower refractive index is said to be optically rarer medium. Let us see this with the help of an example. Take an example of two mediums, medium M1 and medium M2. Medium M1 is optically rarer medium and medium M2 denser medium. So what can you say about speed of light in both these medias? I can say speed of light is more here and speed of light is less in case of M2. Placing M1 in denominator over here will decrease the overall fraction, and placing M2 in denominator over here will increase the overall fraction as the denominator decreases. So I can easily say that optically rarer medium has lower refractive index and optically denser medium has higher refractive index. Let us evaluate or learn few refractive index which we may be using regularly in this chapter. Air 1.0003, water 1.33, ground glass 1.52 and diamond 2.42. Relative refractive index. What we saw earlier was absolute refractive index, in which speed of light in medium was compared with speed of light in air or vacuum. But when light passes from medium 1 to another medium 2, we call this relative refractive index. So here it is represented by 1 and 2. Here 1 means the initial medium of light, and 2, which is written over here in subscript, is the medium in which light enters. So in this case, the relative refractive index can be calculated by speed of light in medium 1 divided by speed of light in medium 2. Now please note this same thing can be asked as the refractive index of medium 2 with respect to medium 1. That means the light is entering into medium 2 from medium 1. So even in that case, it will be written as 1 and 2. So do not get confused over here. When I say light passes from medium 1 to another medium 2, Or I can even say that refractive index of medium 2 with respect to medium 1, which means light is entering into medium 2 from medium 1. Similarly, if I say the medium 1 with respect to medium 2, refractive index can be calculated as speed of light in medium 2 divided by speed of light in medium 1. I hope this all thing is very clear, because before starting with the sum of this particular relative refractive index, you need to understand the concept that light is traveling from one medium to another medium, and you have to be very careful in putting the speed of one speed of light in numerator and other one in denominator. The speed of light from where the incident ray is coming is medium 1 here, and the speed of light in which the light ray is entering is medium 2. Example: the refractive index of glass is given as 1.65 and for alcohol it is 1.36 with respect to air. Find the refractive index of glass with respect to alcohol. So here refractive index of glass is given, nothing else is given. So this simply means this is absolute refractive index, and this means that refractive index of speed of glass is compared with speed of air. And here also speed of alcohol is light in alcohol is compared with speed of light in air. So when I say air to glass, this means speed of light in air divided by speed of light in glass is 1.65, and here refractive index of alcohol is 1.36, which means speed of light in air is compared with speed of light in alcohol. Now what I want to find out is speed of light in glass with respect to alcohol. In that case, what I need is I'll take the refractive index in glass divided by refractive index in alcohol. Why? Because refractive index of glass means speed of light in air by speed of light in glass divided by refractive index of alcohol means speed of light in air by speed of light in alcohol. This here is divided. On putting multiplication sign, changing it with multiplication sign, I reciprocate this number, this fraction. So it will be speed of light in air divided by speed of light in glass multiplied by speed of light in alcohol by speed of light in air. This cancels speed of light in air, and what we get is speed of light in alcohol by speed of light in glass. That was our requirement. So calculating 1.65 divided by 1.36, we get 1.21, which is refractive index of glass with respect to alcohol. Thank you.